use the binomial series to determine the expansion 2x minus 3y raised to power 4, isn't it? So, when the binomial expansion is raised to power 4, then it means we have how many terms? 5 terms. So, if you have a plus x raised to power n, what do we have? Our power is n, so the first coefficient there is n combination 0, isn't it? N combination, then x is raised to power 0, isn't it? Then a is raised to power n minus 0. Are we together? Then plus the next coefficient is n combination 1. Then our x is raised to power that 1, isn't it? And a is now raised to power n minus 1, isn't it? Then you move on, plus the next is n combination 2. Our x is raised to power 2 and a is raised to power n minus 2. Are you together? Then you move on, plus the next one is n combination 3, isn't it? Then our x is raised to power that 3, isn't it? And our a is now raised to power n minus, because the sum of those two powers must add up to n, isn't it? Then the next one, we have n combination, then our x is raised to power that 4, isn't it? Then our a is raised to power n minus 4. So we will reach that term when the highest power is 4. According to, for us to meet the condition of our, what we want to expand using the binomial theorem here, isn't it? So when n is raised to power 4, when your n is 4, it means we have 5 terms. 1, 2, 3, 4, 5. Meaning the highest term they will reach is when x is raised to power 4, the highest power, isn't it? So you come here, because we have x here, we can now say you let this to be x1, isn't it? Are we together? After writing the whole formula is when you let it to be x1. Then after that, you now come and do the substitution. Look here. What is your problem? It is 2x minus 3y raised to power 4. So if you look at this, what do you see? What is your a? You can see here, what is your a? Your a is 2x, isn't it? So it means where there is a, we put 2x. And your x is, your x1 is, where there is x1, we have negative 3y, isn't it? Yes. As in the position of x1 is occupied by negative 3y. So it means where there is x1, we are going to put negative 3. And our n is 4. So we're just doing substitution, isn't it? Are we together? So it means the first one here, the first coefficient here is n combination 0, n is 4. It is 4 combination 0, then our x1 is what? Negative 3y, you see? So we have negative 3y raised to power 0, and our a, which is 2x, isn't it? 2x. 2x is raised to power n is 4, isn't it? 4 minus 0. Are we together? Are we together? Yes. Then you move on to the next one. Our n is 4. That is 4 combination 1. Then our x1 is raised to power that 4. x1 is negative 3y is raised to power this one, isn't it? Then our a, which is 2x, is raised to power 3. n minus 1. 4 minus 1, isn't it? Because n is 4. Are we together? Yes. Where there is n, you put 4. Where there is n, you put 4. When you are doing the substitution, isn't it? Where there is n, you put 4. You go to the next one, n, which is 4, isn't it? n combination 2. So that is 4 combination 2. Then our x, which is negative 3y, is raised to power that 2, isn't it? And the other one, which is 2x, is raised to power 4 minus 2, which is the sum of those two powers must always add to your power 4, isn't it? Yes. Then the next term, we have 4 combination 2, meaning we are going to n combination 3, isn't it? And our x1, which is negative 3y, is now raised to power that 3, meaning we are in this term, isn't it? Are we together?
Yes.
And your a, which is 2x, is now raised to power 1, 4 minus 3, isn't it? Then we are in this last term, 4 combination 4. When we have 4 combination 4, it means we've reached the last term, isn't it? Are we together?
Yes.
So it is plus 4 combination 4, then our x1, which is negative 3y, is raised to power that 4, isn't it? And our a, which is 2x, is raised to power 4 minus 4, 0. Are we together? So it means we've reached the last term. Once our power is 4, if we have 4 combination 4, that is the last term, isn't it? So can you now start giving me the coefficient? We are simplifying. 4 combination 0 is 1. You are pressing that. 4 combination 0 is 1. 4 combination 1 is 4. Isn't it? Then what is 4 combination 2 to give you that coefficient?
6.
Is 6, isn't it? Then 4 combination 3 is 4, isn't it? Then 4 combination 4 is 1. So those are the values we are going to substitute in the coefficient, isn't it? So anything raised to power 0 is 1, isn't it? So you can see the whole of this term is raised to power 0, meaning it is 1. Are you seeing that? The whole of this term also is raised to power 0, meaning it is 1. Anything raised to power 0 is 1. So we can now simplify because we've substituted everything, isn't it? 4 combination 0 is 1. So we have 1, 2x raised to power 4, isn't it? So you move 2 raised to power 4 is 16. Then x raised to power 4. Then times your 1, you just remain with 16. X raised to power 4, meaning we've simplified that term. Are you seeing? You move to the next one. Look at the next one. Here, we have 4. 4 combination 1 is 4, isn't it? So we have 4. Then negative 3 raised to power 1, it is just negative 3. Y raised to power 1 is just y. That power is for everything inside the bracket, isn't it? Then move on. 2 raised to power 3 is 8, isn't it? Then x raised to power 3 is. See, now this is now what you simplify, isn't it? So what do we have? 4 times negative 3 times 8, isn't it? 4 times negative 3 times 8, what do we have? Negative 96. Yes. So negative 96, then our x is raised to power 3 and our y is just y, isn't it? See, we've simplified that term. Yes. Are we together? Yes. So we are done with that term. We move to the next term, isn't it? The next term, you start. 4 combination 2 you found is 6, isn't it? Then negative 3 squared. Remember, negative squared is positive, isn't it? That square which is outside is for everything inside. Negative squared is positive, 3 squared is 9, isn't it? Then y squared is just y squared like that. Are we together? We are done with that. Then 2 squared is 4. Yes. Then x squared is x squared. Then start with the numbers. 6 times 9 times 4. 2 positive 216. Yes. Then we have our x is raised to power 2 and our y is raised to power 2. Are we together? Yes. So it means we've simplified that term. Is that okay? Yes. We've simplified that term. We move to the next term. The next term is this, isn't it? Is that okay? Yes. So we found 4 combination 3 was 4, isn't it? Then negative 3 cubed. Negative, when you cube, you get negative. You must put it in bracket. So just put in bracket negative 3 cube. If you don't put it in bracket, it means you are only dealing with 3 cube but not negative 3 cube. Are you seeing that? So negative 3 cube, you found it is negative 27, isn't it? Then y cubed is y cubed. This power 3 is for everything inside the bracket, isn't it? Then you move on. 2 raised to power 1 is x raised to power 1 is. See, you've now gotten rid of all the brackets there. So start. 4 times negative 27 times 2. Negative 2. 16. Negative 216. Then our x is just x and our y is raised to power Power 3, isn't it? Are we together?
Yes.
We've simplified that term. We move to there, we are in the last term. Are you seeing how it is simple? So the last term we have 4 combination 4 we found was 1, isn't it? Then you move negative 3 raised to power 4 must be inside the bracket. If you don't put negative 3 inside the bracket like this raised to power 4, you will get a wrong answer. It means you are only raising 3 to power 4 but not negative if you don't put the bracket. Are you seeing that? So negative 3 raised to power 4, you found it is positive 81, isn't it? Then y raised to power 4, isn't it? Y is also raised to power 4. You get y to power 4 like that, isn't it? So in the end, that was 1. 1 times 81 times y raised to power 4, so you get plus 81 y raised to power 4. Must be inside the bracket. So you see, you dealt with the whole problem. Negative raised to power 4. Negative means if you raise a negative number to an even power, it becomes positive, isn't it? If you raise a negative number to an odd power, it remains negative, isn't it? Very good. So that is how to solve that kind of problem. Are we together? Good. So that is that.